Good morning, friends. Last lecture we are to end of this first chapter. Therefore, you are first in the first section. Therefore, two chapter is over, and this is the third chapter that about the confirmation of the compound and the justification. Okay. In this lecture, we have to discuss about the three compound and its justification and its confirmation. Okay. Therefore, the first compound is about the cyclohexane 1,4-dione. Dione means therefore it is a two carbonyl group and is called as dione. Okay. Therefore, the firstly it shows the exist in non-chair conformation in liquid and solid states. Okay. Therefore, the cyclohexane 1,4-dione. Okay. This cyclohexane 1,4-dione it exists in non-chair conformation. It exists in non-chair conformation. Look at this. Look at this conformation. Okay, this conformation is not in chair conformation. This is conformation in non-chair conformation. Okay, then the four flexible conformer. This is the four flexible conformer. It is a possible last one. D is a more stable. Means this D is a more stable conformer into the cyclohexane 1,4-dione. Okay. Then the dipole moment of cyclohexane 1,4-dione it is very small but not the zero. Okay. Therefore, the cyclohexane 1,4-dione this is the conformation of the cyclohexane 1,4-dione and its dipole moment is very small but not a zero. This dipole moment in 0.1 but not a zero of the dipole moment of the cyclohexane 1,4-dione. Okay. And this is the conformation. Okay, in this conformation, therefore this is, look at that is a 1,4-dione. This is also the 1,4-dione. This is also the 1,4-dione and 1,4-dione. But this conformation into the both conformation, this is also in both conformation, and this is in spiro compound. This is included into the spiro conformation. Okay, therefore this D is a more stable. D is more stable. Why it is more stable? Because the four flexible conformer are possible. Therefore, these four conformer are flexibly conformation are possible, but the D is more stable. Why D is more stable? Because it shows the carbonyl group into the equatorial. Therefore, it shows the carbonyl group into the equatorial. Therefore, no steric interaction between them. Therefore, it is a more stable. Therefore, D is a more stable. Okay. This is the conformation of cyclohexane 1,4-dione. Okay. This is the conformation of cyclohexane 1,4-dione. This is the first structure, that is about the cyclohexane 1,4-dione, and it is a irreversible reaction to formation of this type of the product, that is in both form. Okay. And then in presence of it is formation of spiro compound, that the carbonyl group is in axial position. Okay. And then it is a formation into the carbonyl spiro compound, and it is in equatorial position. Okay. This is all about the cyclohexane 1,4-dione, its conformation and its justification. This is 3 points are the justification of this cyclohexane 1,4-dione. Okay. Therefore, next compound is Twistane. Okay, this is the first compound, that is about the cyclohexane 1,4-dione. Okay, in cyclohexane 1,4-dione, therefore the four flexible conformation are possible into the cyclohexane 1,4-dione, and therefore the D conformations structure, though D conformation it is a more stable than the 3. Why it is more stable? Because this carbonyl group 1,4 carbonyl group is in equatorial, therefore no steric interaction between them, therefore it is more stable than the 3 conformation. Okay. Then the dipole moment of cyclohexane 1,4-dione it is very small. But not the zero. Okay, dipole moment of 1,4-dione it is very small but not a zero. Okay, this is the justification. Of these 3 points of the cyclohexane 1,4-dione, and it is a conformation of cyclohexane 1,4-dione. Okay, therefore the 2 to 3 marks question asked on this conformation and the justification of the compound. Okay, therefore the second compound of the conformation, that about the twistane. Okay, twistane. In the twistane, therefore the more complex example, it is provided by the twistane of the D2 symmetry containing the 4 equivalent chiral center. Okay, and it is existing to enantiomeric form. It is existing to enantiomeric form. Okay, look at this. This is the twistane structure. Okay, this twistane structure. Therefore, how the justification? With justification, it is formation for this. That about the more complex example, it is provided by twistane of D2 symmetry containing. Okay, this is the D2 symmetry. This symmetry is a D2 symmetry. Okay, this D2 symmetry containing the 4 chiral center. Okay, this star, it shows the 4 chiral center. Okay, this star, it shows the 4 chiral center. Okay, these 4 chiral centers, it exists in 2 enantiomeric form. It exists in 2 enantiomeric form. Okay, look at this. This is the first form, first enantiomeric form, and this is the second enantiomeric form. Okay, this is first enantiomeric form and this is in second enantiomeric form. You are to center of this twistane ring. Therefore, it is the first enantiomeric form and this is the second enantiomeric form. Okay, this is the first justification of the twistane. That about the more complex is an example provided by the twistane and D2 symmetry provided by the twistane by D2 symmetry. It containing the 4 chiral center. It containing the 4 chiral center, and this 4 chiral center, it exists in 2 enantiomeric form. It exists in 2 enantiomeric form. 2 enantiomeric form मध्ये तुमचे 4 chiral centers are existed. Okay, then it shows the center of chirality of the molecules. Okay, this D2 symmetry, this twistane ring, it shows the center of chirality of the molecule. Look at this. This is the center of chirality of the molecules. Okay, center of chirality. Okay, then it is a center of chirality of the molecule. Then the example of the fixation in chair form. Its example of the fixation in chair form of the adamantine fixation of the board form, means the adamantine fixation in the twistane, that about in board form, and in the pentasterane that the fixation twist form in pentasterane, that the fixation of in the twistane, means the pentasterane fixation. Look at that, the pentasterane and the fixation of twist, pentasterane's twist form in twistation, means pentasterane twist form is a twistane. Okay, this is all about the conformation and the justification of the twistane. Okay, this is the conformation, this is the justification and the conformation of the twistane. Okay, this is the second compound. Then third compound, that about the bicyclo 2,2 octane. Bicyclo 2,2 octane. You are to also known about in the first chapter. Okay, we are to discuss about the first lecture, that about the nomenclature of the bridging system and the fusing system. In the bridging system and the fusing system, we are to discuss about bicyclo nomenclature. Okay, in this bicyclo, we are to discuss about this example, that about the bicyclo 2,2 octane. Okay, therefore in this compound, therefore it is interesting in bridging system. Okay, you are to also know about the bridging system. In the bridging system, we are to discuss about the nomenclature of the bridging system, Narode.A.M system. Okay, therefore it is interesting in the bridging system. It is interesting in bridging system, that the bicyclo 2,2 octane, it is interesting in bridging system, which is 1,4 position of the cyclohexane. 1,4 position of cyclohexane. Okay, this is the 1,4 position of cyclohexane, and the bicyclo 2,2 octane by a Diels-Alder reaction. Bicyclo 2,2 octane by the Diels-Alder reaction with the starting of the cyclopentadiene. Okay, therefore this bicyclo 2,2 octane, this ring, it is a formation by Diels-Alder reaction with the starting material is about cyclopentadiene. Okay, with the starting material about cyclopentadiene. This is the starting material of the cyclopentadiene. It is useful in the Diels-Alder reaction to formation of bicyclo-2,2 octane. Formation of bicyclo-2,2 octane. Okay. Then the extra angle strain of the Narode-A.M system to about the 6.3 kilocalorie per mole. Okay, this is the Narode-A.M system, and this Narode-A.M system it have the extra angle strain. It have the extra angle strain, and its system to about its energy is about 6.3 kilocalorie per mole. Means the extra angle strain in the Narode-A.M system and its system's energy is about the 6.3 kilocalorie per mole. Okay, this is all about the justification of the bicyclo-2,2 octane. Okay, then geometry. Then geometry. The geometry is about the adjacent methylene system. All the protons are eclipsed. Okay, in this bicyclo-2,2 octane, therefore all the methylene groups, all adjacent methylene system, all the protons are eclipsed. Means methylene systems, all the protons are eclipsed. Okay, this is all about the geometry. Then the relation of the hydrogen, that the hydrogen shows are in homotopic. Okay, all the hydrogen shows into the bicyclo-2,2 octane, and that all hydrogen are in homotopic. All hydrogen are in homotopic. Okay, therefore the no distinction between endo-exo substitution at the CH2 enantiomers. Okay, therefore no substitution distinguish between the endo and exo substitution. No distinction between endo and exo substitution at the CH2. At the CH2, therefore it shows the 2 enantiomer. Therefore it shows the 2 enantiomer. Okay, look at this. Okay, this is the 2 enantiomeric form. This is 2 enantiomeric form. Okay, therefore we have to calculate that the 1, 2, 3 and the 4, then 1, 2, 3 and 4. Okay, this is the 2 enantiomeric form. This is the first enantiomeric form and this is the second enantiomeric form. This form in the no distinction between endo and exo, and that the substitution at the CH2, and it shows the 2 enantiomeric form. Okay, and this is the conformation of bicyclo-2,2 octane. Okay, this structure it shows the 1,4. This structure shows the 1,4 position of the cyclohexane. 1,4 position of cyclohexane. This is the bridge ring system. This is the bridge ring system in the boat form. This is the bicyclo-2,2 octane, that the 1,4 position. That the 1,4 position in the boat form. In boat form means this bicyclo-2,2 octane, that the 1,4 position of cyclohexane in boat form, and that called as the bicyclo-2,2 octane. That called as bicyclo-2,2 octane. Okay. And you have to also know about the nomenclature of this compound, that about the you have to firstly that the bicyclo ring. Okay, 2 or more compounds are common, therefore we have to start it with the bicyclo. Therefore no substituents it is attached on this ring, therefore we have to start it with firstly bicyclo. Then into bracket the bridge carbon atom. Okay, therefore it shows the 2 bridge carbon, it shows the 2 bridge carbon, and it shows the 2 bridge carbon atom. It is into the bracket, and therefore total number of carbon is 8, and therefore it shows the octane. Okay, this is all about the conformation of bicyclo-2,2 octane and its justification of the bicyclo-2,2 octane. Okay, next time we discuss about the cis-1,3 ditertiary butyl cyclohexane and the trans-1,3 ditertiary butyl cyclohexane in next lecture. Okay, thank you.